Hello my dear students. Today we are going to discuss about A-star algorithm. It's a type of heuristic search algorithm and we can say that it's an advancement of best first search. And here the star means optimality. Okay, so moving on to what A-star algorithm is. First, we can say that it's a search algorithm, or in other words, it's a best pathfinder algorithm, because this algorithm uses some heuristic functions which combines a heuristic value and a cost value, and it helps to find the path with least cost to reach the goal node. That's the basic concept here. So simply, it is used to find the lowest cost path between two nodes. So we can say that this is one of the search algorithms among the previous ones that we have discussed. This method is something different because it provides most optimal results. And when we talk about that it's an advancement of best first search, it gives a more promising result. Okay, so A-star algorithm also finds the lowest cost path between the start and goal state. Where changing from one state to another, it requires some cost. So we'll see it in detail and how it works. We'll see it. So this is the heuristic function that we are using in this algorithm. F of n is equal to g of n plus h of n. Now, what is this f of n, g of n, and h of n? It is being given here. If we have three nodes A, B, C, and suppose we are starting from A, not only 3, we can take about 6 or 7 nodes. We are starting from a node A and we have to reach a node F. So there may be many different nodes combined in different types or different ways, and we have to reach from A to F in a shortest path or shortest cost. So what we will do here? For the optimality purpose, the A-star algorithm uses this function to reach from A to F in a shortest path. So I'll give you the definition of g of n, h of n, and f of n. The distance between the start state and current state, this is represented by using g of n. That means not the distance actually, it's the cost. So the actual cost path from the start state to the current state, that has been mentioned by using g of n. And h of n means the cost of the distance from the current state to the goal state, and the sum of these two, or the cost from start state to goal state, is mentioned by using f of n. So this is somewhat theoretical and we'll see how practically it is being implemented. So we have an elaborate algorithm and the corresponding details regarding to it, but before moving on to somewhat detailed theoretical aspects, I'll first show you how it has been implemented. So let's see a graph here, and we are going to traverse from S to D. That means S is the initial node and D is the destination node. So there are many different paths which leads from S to D, and I would like to find the best path for that. And I'm not only using the cost, but also I'm using a heuristic function, that is h of n. So I am adding the cost along with the heuristic function to get an f of n value, and by using that f of n value I am finding the least cost path or the optimal path. So let's check how this has been implemented. So we are starting from S. So first of all we have to check the different path starting from S. That means S to A and S to B, the direct paths. The first two paths that we are going to check is S of A, S to A and S to B. Then we'll find the f of n values for both paths, S to A and S to B, and we will pick the smallest path or the path having the least value of f of n. So we'll see how it has been done. So we are starting from S, and we would find the f of n value for each path from S at first. So using the formula of f of n is equal to g of n plus h of n, we are going to do this. And there are two paths starting from S, that is S to A and S to B. So I'm taking the first one, that is S to A. And for this, how can I calculate the f of n value? As we all know, the concept is f of n is equal to g of n plus h of n. That is a formula. And how it is being applied. If we are taking s and a, s to a, this node is there. So how can we find the f of n value of that particular path? Here, the g of n means the cost to reach from s to a. That means this one. The cost to reach from s to a is equal to 1. Okay, and what is h of n? H of n means the heuristic value of a, not s. It is a, the final node. If there is 3 nodes, that will be the heuristic value of the third one. That means the final node. So here the heuristic value of a is 6. So we are adding 1 with 6 and we will get the value 7. I think it's clear to you. So finding s to a is f of n value, g of n plus h of n. G of n means the cost value from s to a, and that is 1 here. And we are writing 1 plus h of n, heuristic value of the node. Heuristic value of which node? Not s. It is the heuristic value of the node a, that is 6. We are adding 1 plus 6 and we are getting 7. And the same is done for the path s to b. What happens there? S to b, f of n value, how it has been calculated? G of n plus h of n. What is g of n? S to b. The g of n value means the cost from s to b, that is 4. That's been given here. And what is the h of n value? As it is from s to b, I would like to take the heuristic value or the heuristic function value of the node b, because the path end in b. That's why the heuristic value of b is 2. That's been added with 4 and I've got 6. So this is the first step. And now what I have to do next is I have to pick the smallest among these 2 paths, and from that I have to proceed. And this is the concept. So I found that among these 2 paths starting from s to a and s to b, I have got s to b as the shortest one. That means it have got value 6 and for this it is 7. So I am picking s to b and I am proceeding with s to b. So from the path found, s to b hold the lowest cost. So find the paths from s to b. How it is calculated. Let's check. So s to b is already there and we have to find the paths from s to b, that is s to b to c. Only there is a node c which is coming from b. That's why the next path from s to b is s to b to c. So see here, this is an array actually. Actually for implementing this particular algorithm, we are using 2 arrays, close and open. So without struggle or tracking it more easy, I'm using a single table here and I'm representing how it is being done. So at first we have found the path s to a and s to b, and the f of n value was 7 and 6, and from this s to b we have selected, and when we select a path we have to take it from the array to another location. So I am showing it by using a cross and I have marked the color as blue. So I have removed this particular entry from the table. So now I have s to a and s to b to c with me. Okay, where I have got s to b to c? When I have considered s to b as the lowest cost path, then I am considering the path or the subpaths of s to b, that is s to b to c. So how I could find the function value of s to b to c? Let's check. F of n is equal to g of n plus h of n. And what is g of n? G of n means the cost of reaching from s to b to c. Not from s to c, it is from s to b to c. So how it is done? From s to b it is 4 and from b to c it is 2. That is added here, 4 plus 2 plus the heuristic function value of the last node, that is c, that is h of n. What is the heuristic function value of c? That is 1, and I am adding 1 with here. And I have got 4 plus 2, 6 plus 1 is equal to 7. I have entered it to the table. That's why I have got s to b to c, heuristic value is equal to 7. So now in the list I have 2 entries and both entry values are same and I can pick any among them. Okay, so now both S of A and A not here it is not S, sorry, here it is not A to B to C, it is what? It is S here, not A. It is S to B to C. I have written here, it is correct. So we have two paths here in the list, that is S to A and another one is S to B to C, and both function values S to A and S to B to C are having the f of n value 7. So I cannot pick any one because no smaller values there, both are equal, so I can pick randomly. So I am selecting S of A here or S to A here. Picking S of A means what, or picking S to A means what? I am removing this entry from this table or list and I am entering the subpaths of S to A to this list. Okay, so what happens is I have removed S to A from the list and I have entered the subpaths of S to A. That means S to A to B, S to A to C, S to A to D to the list. So see, S to A to B, S to A to C and S to A to D I have entered to the list. Now I would like to do what? Find the function values of all the paths that I have found. So how can it be calculated? Let's say, so find the path from S to A, and there are three paths from S to A, that is S to A to B, S to A to C and S to A to D. So find the value of S to A to B first. So f of n is equal to g of n plus h of n. So how can it be done? S to A, the g of n value means the cost value. That means S to A 1, A to B 2. So 1 plus 2 plus the heuristic function value of B. What is the heuristic function value of B? It is 2 here. So 1 plus 2 plus h of n 2. So 1 plus 2 3 plus 2 5. Now S to A to C, the cost from S to A 1, A to C 5. That's been written here, and the heuristic value of C, that is 1, that's here. So 1 plus 5 plus 1 is equal to 7. Now S to A to D, S to A 1, A to D 12. So 1 plus 12, and the heuristic value of D, that is 0. So I have written here and it equals 13. Now see which among these three, or I have entered all the details, and these two entries have been removed, and now I am remaining with the 1, 2, 3, 4 entries in the list, and among which is the smaller one, or which is the shortest one? Yes, it is S to A to B with the heuristic, not the heuristic, as a function value is equal to 5. So I am going to pick that value. Okay, so I am removing S to A to B from this list, and I am going to introduce the subpaths of S to A to B. What is the subpath of S to A to B? S to A to B have a subpath, a single subpath, that is C. So let's check. Let's proceed with the path of S to A to B. So find the paths from S to A to B. There is only one path from S to A to B, that is S to A to B to C. So I am going to find the heuristic function value, not the heuristic function value, the function value of S to A to B to C, that is f of n is equal to g of n plus h of n. And what is the g of n value? S to A 1, A to B 2, B to C 2. So 1 plus 2 plus 2 plus the heuristic function value of C. What is the heuristic function value of C? It is 1, and the value equals 6. As S to A to B to C is the shortest of all the paths of the list, check which is the shortest. S to A to B to C is the shortest because it is having a value 7, 7, 13 here and here 6. So among the list, which is the shortest? S to A to B to C. So as the newer one, that is S to A to B to C, is the shortest of all the paths in the list, we can now proceed with this path. Okay, shall we? Yes. And we are removing this and trying to find its next generation, or the subpath of it, that is S to A to B to C to D. Okay, so we shall find it out. So find the subpaths of S to A to B to C, that is there is only one path from S to A to B to C. Here it's missing. that is S to A to B to C to D. So I'm going to find the function value here. F of n is equal to g of n plus h of n. What is g of n? The sum of the cost values. S to A 1, A to B 2, B to C 2, and C to D 3. 1 plus 2 plus 2 plus 3. And the h of n is equal to the heuristic function value of D. That is 0 here. So I've written 0. And what is the sum? It equals 1 plus 2 plus 2 plus 3 equals 8. Okay, and I've entered that value to the list. So check what is remaining. 7 here, 13 here, and 8 here. So which is the shortest? The shortest is 7. And we have 2 paths which is holding the function value 7. So we can randomly pick any among this. So let's pick the first one, that is S to B to C. Okay, so I've written S to B to C. So we have to find the paths leading from S to B to C, that is S to B to C. There is only a single path leading from this, that is to D. So S to B to C to D, and I'm going to find the function value here, and it is g of n plus h of n. And what is g of n? S to B 4, B to C 2, and C to D 3. 4 plus 2 plus 3, and h of n is equal to the heuristic value of the last node, that is D, that is 0. And when adds 4 plus 2 plus 3, it is equal to 9. And I am entering this to the list. Okay. Now check the remaining elements in the list and find the shortest. Which is the shortest? S to A to C is the shortest. So I am going to proceed with S to A to C. So remove S to A to C from the list, and I am going to find the paths leading from S to A to C. So find the paths from S to A to C. There is only one path, that is S to A to C to D. So write the function value. F of n is equal to g of n plus h of n. And what is g of n? G of n means the cost value of S to A to C. S to A 1, A to C 5, then C to D 3. So 1 plus 5 plus 3, and h of n is equal to the heuristic function value of D, that is 0, and it is equal to 9. I have entered that to the end of the list. Now check what exists. Okay, see, we have checked all the possible paths in this particular graph. So we have removed all these shaded elements from the list, and what remaining in the list is the paths leading from S to D. And see, now what we have to do is find the shortest, which is this. S to A to D is there, holding a value 13. S to A to B to C to D is there, holding the value 9. S to B to C to D, holding the value 9. S to A to C to D, holding the value 9. So which is the shortest? From the remaining one, we have to find the shortest, that is S to A to B to C to D, holding the function value 8. That's it. So no more path to traverse. The paths left in the list are those leading to the destinations, and what we have to do is pick the shortest among them. Okay, hope you have understood. So now we'll see the theoretical side of this implementation of the algorithm. So for implementation of A-star algorithm, we will use two arrays, namely open and close. Open is an array which contains the nodes that has been generated but has not been examined. Close is the array which contains the nodes that have been examined. That means, see the array we have used here. What happens here? The shaded rows, that means we have moved all these shaded elements from the list. That means 1, 2, 3, 4, 5, 6 entries, which is shaded blue, is the elements of the array close. And that means these all are examined ones. That means we have found the subparts of that. Okay, and all these nodes are the unexamined ones. So this values will be in the open array, and the blue shaded values will be in the closed array. That's why I've given a cross mark here, so that you can easily understand it. So you have two options. Either you can write like this in the implementation, or you can use two different lists and when crossing from this list, you can take these elements and insert into another array. It is no issues are there. You can use anything. I have used this technique so that it will be more understandable to you. That's it. Okay, that's what we have explained here. So open is an array which contains a node that has been generated but not been examined, and close contains the values which is already examined or already traversed. Alright, now this is the A-star algorithm. It's very important. Normally in the second module, the question asked are actually the repeated ones. A-star is asked frequently, and another question is the anomalies of hill climbing algorithm, and also the difference between the heuristic search and uninformed one is that's also asked. But A-star and anomalies of hill climbing are a type of frequently asked questions, so it's very important, and you have to learn the algorithm because it holds marks. Okay, so see the algorithm now. I think it will be more easy for you now. So place a starting node into open and find its f of n value. So we have placed it. Remove the node from open having the smallest f of n value. We have checked it. So if it is the goal node, then stop and return success. Otherwise, what we have to do? Remove the node from open, find all its successors. Okay, find the f of n value of all the successors, place them into open, and place the removed node into close. We have just mentioned as a cross there. That's it. That's only the difference. So go to step 2 and repeat the process again. So the checked nodes are being taken to an array close, the others are being checked in open, and we are traversing it. Okay, so I'll repeat again. In this algorithm, we are starting from an initial node. Here it is S, and we are placing that node and finding the successors of it, and we are finding the f of n value in each step, and we are frequently checking the shortest or the smallest f of n value, and we are picking it, and if we are checking whether it is the shortest, and the process has been repeated. Okay, and the examined ones are being taken to the closed node and the other closed array, and the unexamined ones are being kept in open. And it is not an issue if you are using the same list. You can use the same method that I have followed. Okay, hope it is useful to you. Okay, so I think it is clear to you now. So you just check this graph and just traverse it through the arrays and find the values, and I'll give you more examples to work out with. Okay, thank you.